summarize the tools and platforms which we'll be using as part of the roadmap, we'll be working on hardware platforms like PIC, STM32, ESP32, Arduino, and Raspberry Pi for developing and prototyping. In case you don't have the access to the hardware, you can still work on assignments and projects using simulation tools. For our online students, we are recommending to use simulators like PicSimLab, Wokwi, and KMove to develop similar applications and projects instead of using the real board. Apart from hardware platforms and simulation tools, we will also be using IDEs and SDKs. We will use IDEs like STM32Cube or MPLAB IDE, as well as Arduino IDE as well. Debugging tools like GDB and UART for troubleshooting also will be used extensively. Now let's have a look at which hardware platforms we are going to use as part of embedded systems and IoT development. I'll also share some of the simulator tools and IDEs which will be used to develop the modules and projects. As part of embedded systems and IoT course, we will be using several boards to develop embedded applications. One such board I'm holding right now is PIC-based development kit. In this development kit, we will be using PIC 16F or 18F series microcontrollers, which are 8-bit controllers from Microchip. So this board has several peripherals. As you can see, it has a CLCD display, it has a matrix keypad, digital keypad, it has interfaces which can be used to interface with external devices, including CAN node is supported. It has a RTC which can be interfaced using I2C. It has an SPI wherein we can interface it with an SD card, and so on. So this board we are using primarily to teach you bare metal programming based on PIC microcontroller. In terms of software, we're going to use MPLAB IDE to write the program and build the program using X8 compiler. Similarly, we're going to use other boards as part of embedded systems course. So one such board is STM32 Discovery board. This board runs ARM Cortex-M4 microcontroller, which is an advanced microcontroller compared to the PIC microcontroller. On this board, we can build more complex applications using the supported peripherals, including it has a TFT display, it has support for ADC and DAC, wherein you can develop DSP based applications because it supports floating point unit. You can use it to interface with Bluetooth and Wi-Fi so that you can build IoT based applications also. It has a 3-axis gyroscope. You can also interface with a accelerometer as well so that you can develop applications in health monitoring systems like pedometers, fall detection, etc. So we'll be using this board to develop ARM Cortex M4 based embedded applications using HAL, using bare metal, as well as FreeRTOS based applications we can run on this platform. Apart from the PIC 8-bit and ARM M4 based development boards, we can also use BeagleBone development board as well as Raspberry Pi. These are quite popular among hobbyists as well as developers to learn embedded Linux. We'll use these boards to learn embedded Linux on ARM platform. For the IoT course, we will be using platforms like Arduino as well as ESP32. So this ESP32 board looks very small in miniature, but it can be used to develop IoT applications with ease because it has built-in support for Bluetooth as well as Wi-Fi. This can be interfaced with several other sensors, which will be part of the Arduino module as well as the IoT gateway module. In addition to using ESP32 and Arduino based boards, we'll be using Raspberry Pi, which can be used to develop IoT gateway based applications. This can run a full-fledged Linux operating system, so you learn how to install Linux, platform like Raspbian and the likes. You'll also install the necessary software and servers like MQTT brokers. You can even run web servers like Apache and the likes so that you can communicate with the cloud. So these are some of the hardware platforms we'll be using as part of the Embedded Systems and IoT course. Now, if you don't have the hardware or you want to experiment with the simulator or the emulators, you are free to do that. For learners who are opting for the online course, we'll be using simulators like MPLAB, Wokwi, and Kemu for developing and testing the embedded and IoT application. Let me show you some of these simulators and platforms available so that you can get a first-hand view. Let me show you one of the simulators which are using for embedded system development. We're using a tool called as MPLAB, which has support for several boards and microcontrollers. As you can see here, several boards including Arduino, Bluepill, which is based upon STM32 ARM Cortex-M3. It has support for PIC microcontrollers. Several PIC-based boards are supported like PIC Genius. It has support for MPLAB 1, MPLAB 2, etc. Other than that, we can use ESP32 based boards which can be used to develop IoT based applications. In terms of microcontroller, for the ARM Cortex-M3 based development, we'll be using a microcontroller based out of STM32F103 controller. Similarly, let me navigate to the PIC based board. For the IoT course, we will also introduce an online simulator called as Wokwi. This simulator has support for different platforms including Arduino, ESP32, STM32, and PyPico. Let's navigate to Arduino. As you can see here in the Arduino landing page, there are several projects which has been posted here. We can click on any of these projects and have a look at it. So this is a web-based IDE which allows you to write code using Arduino platform, and you can also see on the right hand side there is a simulator. Let me just run this application to showcase you how this platform works. As you can see here, I can run the application and I can see the output inside the browser. This is one of the board we're going to use as part of the online based microcontroller module. Here you can see that several peripherals are part of the development board, including simple peripherals like LEDs, peripherals like matrix keypad is available, which will be interfaced using GPIO. You have some switches which can be used to test your interrupts. There are interfaces like buzzer. You have a temperature sensor which is based on LM35. There are relays, and you can also interface externally by using serial communication protocol. There are more devices like RTC which can be interfaced using I2C, and we have EEPROM as well. Overall, you can see that whatever you can see on our real hardware, you can access it using the simulator without facing any challenges. Moreover, if you look at the tool set available here, that it has support for something called as spare parts, which is quite powerful. I can add more input and output peripherals which are listed in the spare parts repository. As you can see here, I can connect an accelerometer, we can connect a pressure sensor which is based on R2C. There are peripherals like DHT11 temperature sensor. We have more advanced sensors as well. You can add more peripherals to your board and interface them by using the GPIOs, I2C, and SPI protocols. Similarly, there are output devices as well, like 7-segment displays, DC motors, LCDs, RGB LEDs, and servo and stepper motors. In fact, it has a built-in oscilloscope, which you can use it for debugging your port output as well as input. As I demonstrated, the MPLAB IDE is quite powerful. We can use it to learn embedded systems and IoT modules without the need for procuring a real hardware. But those who are interested to learn things in a hardware way, we can share the links to the hardware-based boards which are using. They don't cost you much. Let me also show you some of the microcontroller development IDEs, which we'll be using as part of the course. One such IDE is MPLAB X IDE, which is provided by Microchip. We can use this to develop PIC-based microcontroller applications. So this IDE is a full-fledged IDE which consists of an editor. You can see a pane to manage the projects which are available. You can build a project for different microcontrollers, including PIC6, PIC8, 16 and 32-bit controllers. Similarly, if you're going to develop applications based upon STM32 based boards, we will be using STM32Cube IDE, which has several features including a pin configuration manager wherein you can easily configure the pins and do the interfacing without the need to write low-level initialization code. So PICSimLab is an emulator or a simulator which can be used to test your PIC-based programs as well as ARM M3-based programs which you have developed using MPLAB X IDE or STM32Cube IDE. So hope we have clarity on what are the hardware platforms we are using as part of the course. And if you are interested, you can also explore the emulators which are shared in the video. With this, let us see what companies are looking for in terms of skill set and expectations from a candidate. I will be walking you through some of the job listing which is shared by our clients to our placement team. I'll walk you through the job description, the skill expectations, so that you can map to whatever we discussed in the roadmap and relate it with what the companies are expecting for.
And with this, we have come to an end with this video. Roadmap from beginner to Embedded Systems and IoT professional. If you have enjoyed listening to this video, please like it and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to Emertxe's YouTube channel to learn more. Thank you for watching.
They are expecting the skills including C, C++, and Linux internals. If you look at the job description, as you can see, LG expects you to be strong in C and C++ programming as well as data structures and algorithms. They expect you to have a knowledge of operating system concepts and memory management. Importantly, they mentioned that the candidate should have a problem-solving mindset and ability to troubleshoot technical issues. You can also expect a coding round following the initial MCQ round. This will give you the confidence to crack any technical interview.